So we're going to divide, and we can use synthetic division here since we're dividing by x plus 2 for the first one. So we're going to change the sign, and we're going to use a -2 on the outside, and then on the inside, we put the coefficients. So I have 1, 2, -3, and 5. Bring down the 1. 1 times -2 is -2. Add, we get 0. Multiply, we get 0. Add, we get -3. Multiply, we get 6. Add, we get 11. So our answer for this one, we drop a degree, so x squared. Then we have a 0x, which we can exclude, -3. And the remainder is 11 over x plus 2. Okay, on the next one, we're going to put a -1 on the outside. We have a 1, a 3, and a 2. Bring the 1 down. 1 times -1 is -1. Add, we get 2. 2 times -1 is -2. Add, we get 0. So it goes in evenly. Drop a degree. So we have x plus 2. Okay, what we're going to do today is to graph polynomials with a calculator. So it's very similar to what we did before. We're going to solve polynomial equations using a graphing calculator, division, and factoring. Use a calculator to find the zeros. We're going to graph a function using the x-intercepts and the y-intercepts and find the turning points, and then describe the end behavior, increasing, decreasing intervals, and domain and range. And so the first thing we have to look at is how to solve a polynomial. So you want to set your polynomial equal to 0 in order to solve it. You always want to try to factor completely first and set each factor equal to 0. If you can't factor, use a calculator to graph the polynomial function and then identify one root by examining the graph. Then we can use synthetic division to factor further and find our other zeros. So if we look at this first example, if we tried to factor this, right, there's 4 terms, so we would use grouping. If we try to group this and take out the common factor, we'd have x squared and then 2x plus 1. And then I would take out a -1, and I have 7x plus 6. If you notice, these two are not the same. When you're doing factoring, they have to be the same. So this means that you can't factor it. So we're going to ignore that. Okay, so it says examine the graph to find one of the zeros. So if we plug this into a graphing calculator, okay, let me just, okay, if I hit graph, if it wants to work. Okay, so here we have what our function looks like. So this is the function. Now we're going to pick one of the x-intercepts to use. So it's crossing here, and it's also crossing here. You want to pick the x-intercept that's obvious. So these ones are kind of tricky because they look like maybe they're in between the lines, and each line is 1, like each tick mark. So if you look at this one, it's a little iffy, but this one looks like it's going right through 2. So in order to check that, what we can do is you can hit the second button, and you can hit trace. And then number 1 says value. So if you click on the value, you can type in an x value you want it to check, and it will give you the corresponding y value. So if I want to make sure that it indeed does cross through x equals 2, I could type in 2 for x, and if that is an x-intercept, my y value should be 0. So if I hit enter, it's going to tell me 2, 0 is my point. So as long as I have y equals 0 here, I can use that number. So we're going to go back to our function, and we're going to use x equals 2, because that we got from our calculator. So x equals 2 is one of my answers, and that's from the calculator. So what I'm going to do now is I'm going to use that number for synthetic division. So I'm going to put my 2 on the outside, and then I have a 2, a 1, a -7, and a -6. So the 2 comes down. 2 times 2 is 4. 4 and 1 is 5. 5 times 2 is 10. -7 and 10 is 3. 3 times 2 is 6, and remainder 0. So when we divide with the number from the calculator, we should always have a remainder of 0 since it goes in evenly, since x equals 2 is one of my solutions for this. So now, if I rewrite this, I have drop a degree, so 2x squared plus 5x plus 3 equals 0. So now I can factor this. So a times c is going to be 6, b is going to be 5. So the two numbers that I can use here would be 3 and 2. So I can factor 2x squared plus 2x plus 3x plus 3. So I just rewrote that 5x using the 3 and the 2. So now I can group, take out my GCF. So a 2x is going to come out. I'm left with x plus 1. Take out a 3. I'm left with x plus 1. So I'm going to put them together, 2x plus 3 and x plus 1, and set it to 0. So if I set this one to 0, I'm going to get -3/2, and then -1. So my three zeros would be x equals 2 from the calculator, x equals -3/2, and x equals -1. So if we look at the next example, same thing. We want to examine the graph first, and then find one of the zeros from the graph, and then use that for synthetic division. So if we type this into the calculator, and this is what our graph is going to look like. So again, let's examine it. So here's kind of like fishy. We're not exactly sure what those values are. You can use second trace and try any of these values that you think it might be, but just use the obvious one to make your life easier. So obviously it looks like it's going through -1. Let's just double check. So second trace, we're going to go to value, and I'm going to type in -1. So I should have a y value of 0. Okay, and I do. So that means I can use that. So we're going to have x equals -1 as one of our zeros, and that's from the calculator. So now we're going to use -1 for our synthetic division. So we have 8, 2, -5, and 1. 8 comes down, multiply it, I get -8. Add it, I get -6. Multiply it, I get +6. Add it, I get 1. Multiply it, I get -1. Remainder of 0. Okay, so it goes in evenly. So we write it as 8x squared minus 6x plus 1 equals 0. So now from here, we can factor. A times c is going to be 8. B is -6. So multiplies to 8 and adds to -6. We can use -4 and -2. So that's going to come down 8x squared. This is going to come down plus 1. And rewrite this -6x. So -4x minus 2x. And from here we can group it. And I'm going to take out my GCF, which is 4x. I'm left with 2x minus 1. And take out a -1, 2x minus 1. So when we put this together, we have 4x minus 1, and then 2x minus 1 equals 0. So if we solve each, we'll get 1/4, and then we'll also get 1/2. So we have three answers, -1, 1/4, and 1/2. Okay, so these are just the steps kind of written out for you. So use calculator to find the real roots is step 1. So if we plug this into the calculator, -1 is one of the roots that works from the calculator. So once we have that, we use that for synthetic or long division. If you want to do long division with this, the thing that you need to do is you need to change your sign. So if you have x equals -1, if you're using long division, you need to use x plus 1 on the outside. So it's always going to be kind of like the opposite. So I'm going to do synthetic here with negative 1. I'm going to put a 2, a 1, a 0, and a 1. So I'm missing my x term. I have x cubed, I have x squared, and I have a constant, so I have to put in my placeholder. So I'm going to bring down the 2. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. So we have 2x squared minus x plus 1 equals 0. And this is solved by factoring or using the quadratic formula as needed. So if I try to factor this, my AC is 2, my B is negative 1. And nothing's going to multiply to 2 that adds to negative 1, so I need to use the quadratic formula. So I'm going to do x equals negative B, so positive 1, plus or minus B squared minus 4AC, all over 2A. So if we simplify the inside, I'm going to end up with 1 minus 8, so I get negative 7 over 4. And then I can take out my I. So I radical 7 over 4. So this should have 3 solutions. I have negative 1 from the calculator, and then I have 2 that are imaginary. So if I ask you to find all the zeros of a polynomial, and you can do 2 things in this case. So you can always try to factor first. You might not be able to factor. If you can't factor, you can use the calculator to find one of your zeros and then divide. So let's just show this one both ways. So if I want to factor this is treat like a quadratic. So it multiplies to 8 and adds to negative 6. I can use negative 4 and negative 2. So I can write this as x squared minus 4 and x squared minus 2. And then I can factor this one to be x plus 2, x minus 2. And then x squared minus 2 I can't do anything with, so we're just going to leave that. So if I set each one to 0, I'm going to get negative 2. It's supposed to be a negative here. I'm going to get positive 2. And I'm going to get plus or minus radical 2. So I have 4 answers. And I got them just from factoring. I can take the same problem and I can graph it. So if I graph it, I'm going to use x equals 2 as the one from my calculator that I got. So we're going to use 2 on the outside, and we're going to divide. So I have 1. I need a placeholder for x cubed, negative 6, placeholder for x, and then 8. Okay, bring down the 1, multiply it, add it, multiply it, add it, multiply it, add it, multiply it, add it. So now I have x cubed plus 2x squared minus 2x minus 4 equals 0. And I can group this now, take out my common factor, which is x squared. I'm left with x plus 2. Take out my common factor, which is negative 2. I'm left with x plus 2. So put them together, x squared minus 2 and x plus 2 equals 0. When I solve this one, I get x equals negative 2. And then this one is going to give me x equals plus or minus radical 2. So I got the same answer 2 different ways. So if you can factor it, it's a little bit shorter, so you might want to factor it. If you can't factor it, then graph it in the calculator and go from there.